Good evening. Rather, it will be good morning, depending with where you are. Many are watching my videos, and I'm grateful. Thank you. We're here so that we can share knowledge. That even while if we are not there, we have people who can deliver some concepts and help people to also learn. My name is CPA Cleophas. I come from Kenya. Kenya is my home country. So, and currently I'm in Nairobi. So, I want to help those also who are doing research in some areas. And today, because I normally deliver some concepts using the CASNEB past papers, today there is a concept called regression and correlation. That is what I want to do. Regression and correlation. It is what I want to do. But I want to do a past paper question, regression and correlation analysis. Do not struggle with these concepts. You can contact me through my email. You can contact me through the WhatsApp number, and then we can just agree. If you're doing a research, I'll be in a position to also assist you. Then we agree on some terms. Then we just do a good job together. Then maybe in one way or the other, we shall be helping countries and at large, we shall be helping the whole world. So today, allow me to do a simple past paper question so that I simplify this concept. So if you can just even go to your browser, you search CASNEB past papers, then you search a paper called quantitative analysis, quantitative analysis, which we abbreviate as QA. Previously, which used to be quantitative techniques QT. We can read from the same page, or we can have these questions. These are past paper question, December 2023. So I'll do December 2023. So these are exam questions. So when you look at December 2023, question number 3, and I'll do 3B because of time. I'll read the question, then briefly we just do it, and I'll give more explanation regarding this concept of the ranking model is what I want to do. Sometimes it is also difficult to quantify some matters like the beauty. You cannot tell a person or a lady that she has a beauty which is equivalent to 100 kilograms or 1,000 liters. It is not possible to quantify beauty. It is qualitative in nature. So beauty is a qualitative variable, like again, tastes or preference. You cannot say a particular meal or food which has been prepared, it has or the taste of it is maybe 20,000 kilowatts or liters. It is not possible to do so. What you can do, if you're given varieties of different delicious meals, you can rank as per you as one of the judges. You can rank it number 1, this another meal number 2, another one number 3, like that. And that is how The ranking model with regard to the correlation came up. If people are doing an exam, some students have done an exam, I can be judge A, or they are even, I can be judge A, I award marks, or they are doing just, they are doing a presentation. I can rank the best presenting candidate, or the best candidate who did the presentation perfectly. I rank that person number one. And I give maybe 90%. Another one, number two, maybe 85%. So the candidates, I can only rank them. And that is how the ranking model came up. So when you're required to get the correlation measures the bond or the strength between two variables. For example, I am the first judge, I have another judge B, or maybe I'm judge A, another judge is judge B. So you can be required to determine the relationship in terms of the bond, in terms of the ranking we have done as per the given candidates. It can be a strong one, a strong bond or relationship, or a strength, a strong, weak, or maybe very, very strong. So correlation is what I want to do. So when you look at this question, let me read. Those who can even write it, as I also read, I will do so that I read at a speed which you can also be pausing and writing it for you to get for better understanding of what I am doing. The question reads, an insurance company has two claim assessors who must each give approval to customers who wish to lodge a claim for compensation. The manager currently has 8 such customers and has asked each assessor to independently rank the customer claims in order of merit. The rankings are shown below. Customers are there, customer A to H. Assessor 1 did the ranking. Assessor 2 did the ranking. You're given the ranking as per the assessors. Then you're required calculate the rank correlation coefficient of the two sets of ranking and comment on the results. So let me show you the data. So the question is 8 marks. So we are given the customers. So this is an insurance company. It has two assessors. So they are assessing the customer claims for compensation. So you have the customers who needs compensation. We have customer A, B, C, D, E, F, G, and H. I think those are 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're told there were 8 customers. So there is how the assessor 1 did the ranking of these customers. So assessor 1 ranking. Assessor 2 ranking. So what happened? Assessor 1 ranked A number 4. So number 1 is for assessor 1. The one who was ranked, the claim which was ranked number 1 is for the which customer? Assessor 1 claim D was ranked 1. Number 2 is C. Number 3 is H. That is as per assessor 1. That's how you rank the claims. 4 is A. 5, E was ranked number 5. 6 is B. 7, 6 is B. There's no 7. F is 8. Sorry. B is 6 and also G is 6. So that's how they were ranked. So this one is a tie. They were ranked 6-6. And that is why there is no 7. So this what should happen. 1, 2, 3, 4, 5, 6, and this should be 7. So it should be 6 plus. So that is the ranking. So let's continue with what the ranking was done. Let's be. So A was ranked number 4 by SSR2, 8. B was ranked 8. C was ranked 1. D was ranked 3. E was ranked 7. F 4. So there were 2 4s. These are tied. G6 and 2. So 1, 2, 3, 4. Then there's no 5 because there's 4. 2 4s. Then that is the ranking. So if you're given this and you're told to determine calculate the rank correlation coefficients of the two sets of ranking, this ranking is not right. You need to know how it should be. It should have been this: 1, 2, 3, 4, 5, 6, 6. Should be 6, 7. So one was the two of a tie. One should have been 6, the other one 7, but they are the same. So it will be 6 plus number 7. You divide by 2, you get the average, it will be 6.5. So for this one, it will be 6.5. This one, 6.5. So that's the next number, because this 0.5, it is 7 has to be taken care of. So you go to number 8, because 0.5 takes care of the following, number 7. Well, you go to here, 4. Number 5 is not there, so because we have 1, 2, 3, 4. There is no 5, that's why we have 2 4s. So it should be 4 plus 5 divided by 2. This is 9 divided by 2, which is 4.5. So each of them should be ranked 4.5, 4.5. So that's how the ranking should be. So I've corrected that so that I can do the question. So that's how the correct ranking should have been. It is just to trick the students. So this is what you do. After you have this, get the difference between the ranking. And then you square the difference between the ranking. Which I list D for the difference between the ranking, then I square the difference. What do I mean? For example, A was ranked 4 and also 4.5. So it should be 4. The difference between 4 and 4.5 is 0.5. So like say 4 minus 4.5. This is negative 0.5. When you square any negative, it will be positive. Square that, you get 0.25. So difference is squared. 6.5 and 8, 6.5 and 8. The difference is 1.5. You square that. Even if you put it into negative, when you square the negative, it will be positive 2.25. 2 and 1, difference is 1. You square 1. 1 and 2, 3, difference is 2, square 4. 5, 7, difference is 2, you square 4. 8 and 4.5, so 8 less 4.5, the difference is 3.5 squared, I'll get 12.25. 6.5 and 6, 6.5 minus 6 is 0.5, when you square you get 0.25. Then we have the last one, 3 and 2, 1, if you square you get 1. So get the total there of this D squared. Because correlation or coefficient of correlation, which is R, and is equals to 1 minus, this is the formula, 6 sigma or summation of D squared all over N cubed minus N. So you need to work out this one, then you raise it from this 1. So that's how it should be. 1 minus, so work out this. It can be rewritten, this one, don't worry, as N into bracket N squared minus 1, which is the same. So that's why in most of the books you see R is equals to 1 minus 6 summation of D squared all over N into N squared minus 1. When you open this bracket, N times N squared, it will be N cubed. Then N times 1 is N. So this is the same as, this is the same formula. So for me, let me use this one. The first one I've shared, so that you do the working. This R is the correlation or the coefficient correlation. This is what the question requires. you calculate the rank correlation coefficient, the R. So our R would be equals to 1 minus into bracket 6, but you multiply this 6 by d squared sigma d squared. Sigma means your total. Total of d squared. D squared is here, so get the total. So that will be the summation. So let's add this 0.25 plus 2.25 plus 1 plus 4 plus another 4 plus 12.25 plus 0.25 plus 1. I'm getting 25 here. So that is the summation of d squared or sigma d squared. So which is here, sigma d squared. This is a formula. D squared is the difference between the ranking. So I'll put here times 25 all over n is the number of data values. How many candidates were they? There were 8. A, B, C, D up to H. Those are 8 candidates. So it will be 8 cubed minus 8. Because our n is 8. So 8 cubed minus 8. So let me work out this. 1 minus, what is 6 times 25? I'm getting 150 divided by, what is 8 cubed? 8 raised to power 3. Then I realize 8, I'm getting 504. So R will be equals to 1 minus what? 150 divided by the 504, I'm getting 0.2976. So what is 1 minus the answer? Getting 0.7023. So in terms of percentage, it is 70.23%. 70.23%. So how do you comment? If you realize your R is between, for example, 0 to maybe 49%, this is a weak relationship or a weak bond between the two variables. 50 to 64%, this is what we call this a good relationship. 65% to 74, this is what we call as strong. A strong relationship. 75% to, so this in percentage to 99, this is called very strong relationship. That's how you comment, very strong relationship between the two variables. Then 100% is perfect relationship. So if it is 100%, you say it is a perfect relationship. So what about this one? 70.23. 70.23 lies where? 65 to 74. So where you comment to say there is a strong relationship between assessor 1 and assessor 2 ranking. Said the comment you give, if your R is 0.7023, you see there is a strong, because it is between 65 to 74, there is a strong relationship, because this is the question we're doing, between assessor 1 ranking and assessor 2 ranking. So that is what was expected of you in the question. You get 8 marks. Thank you for watching my channel. Thank you for being there to support and subscribe to my YouTube channel. Many have been they are being assisted by this channel, so you can share with somebody on whatever you have watched, whether it is helpful or not. But I know definitely or obviously it will help you. Let's meet in the next class or the next concept I'll be sharing maybe in the course of the week. Thank you.